Right, guys, the second inverse hyperbolic function we're going to look at is the cosine hyperbolic, which is more or less like this. I think I lost symmetry a bit there, but maybe let me just undo it. Let's say more or less. I think that is better. Right. That is y equals to cosine hyperbolic x. We want to get the graph of its inverse, exploiting exactly the same fact that these graphs should be symmetric across the earth. Now here, this number is 1. A number we can get across the axis like that. Here we must get what? 1 altogether. So that point is on the graph. It's actually that point is some kind of a turning point of the graph. Now if we look at this one here, take the same distance across there, then this point here is on the graph. Which means if the curve runs symmetric here, it will come more or less this way. Altogether, then the troublesome point now is this one. This one is going to be thrown across, and they come somewhere here. So this curve is actually going to look more or less like this, and going. This is really a rough sketch, guys. Rough sketch. It's not very good. I don't like it, but I think I hope it gives you an idea. Now, once you've got this curve like this, and you claim that this curve is the curve of cosine hyperbolic second function of x, I've got a big question for you. Is this a function? Why is it not a function? Because it fails the perpendicular test. The perpendicular line test, isn't it? Put a perpendicular here, roughly there, or almost at any point, except here, you're going to get two values. But can we convert it to a function? Yes. What we normally do in this case, we convert it to a function by getting rid of one wing, this wing. We get rid of one wing. You will then see the graph of cosine hyperbolic x is something more or less like this. Because my sketch is too rough there, I'll just draw it roughly. It will be something more or less like this. We've got a 1 there. Then the graph just goes more or less like this. That is the graph of what? Cosine hyperbolic second function of x. All together, guys? Okay. So now, the task I'm going to give you now is to go and think about the graph of tan hyperbolic. Remember, the graph of tan hyperbolic runs almost like horizontally between -1 and 1, isn't it? Now, if you reflect that across y is equal to x, what's going to happen? You are reflecting x across y is equal to x. It's going to become y, isn't it? So which means the graph is going to run upwards, parallel, almost like parallel to what? To the y-axis, isn't it? Yes? The asymptote becomes, the horizontal asymptote becomes vertical asymptote. Altogether. So please go and engage with that one. Maybe there must be some interesting questions there you can be required to answer. Alright. So I think for me, discussing the inverse hyperbolic functions, this is enough. I think I've made sense of the definition. I've also tried to make sense of the graph. Thank you for listening for that part.